But welcome back from lunch. We wanted to make sure that we thanked some of the people who've been supporting us at SICSS-Oxford, which is the Russell Sage Foundation, Alfred P. Sloan Foundation, Oxford Van Houten Fund, Social Science Division of Teaching Development Awards, and Nuffield College, and of course the sociology department here that we're in. That's just a short list of the number of groups that help bring this together. So thank you. Today we're going to talk about computational text analysis. My name's Taylor Brown. I'm a PhD candidate at Duke and a visiting scholar at NYU. And I know that there's a lot of people in this room in particular who have interest. We learned from the flash talks in computational text analysis, but also a lot of experience. And this is not meant to be just me talking at you. Because of that level of interest and expertise, I hope that you ask questions, you help answer questions. If I don't answer them properly, you correct me if I do it wrong. We can debug my code together, like whatever. Let's just make sure that this is interactive, so feel free to interrupt. And if you don't, I'll probably pause and ask you to. I don't actually consider myself to primarily be a computational text analyst, but I have used the methods previously, and can someone let her in? Thanks. And I think one thing that's really neat about these methods is it's pretty easy to go from beginner to the cutting edge in a short amount of time. When we look at the timeline of how computational text analysis has developed, a lot of the progress has been made just in the past couple of years. And I didn't even know how to code when I started my PhD, but I certainly didn't know a lot of these methods, and now I help on a project that a package we'll see later on text networks that's kind of something that's never been done before, but also isn't that advanced and complex. So there's a lot of opportunity to contribute, especially in the social sciences. And the last thing I'll mention before we jump in is that as I was preparing this, I decided to start like a bibliography of foundational and really relevant computational text analysis citations, and I started a Slack channel called Text Citations you can join. And if you have anything to contribute, just put it there and I'll add it to the bibliography, and at the end of SICSS, we'll print it out and you'll have what could be the start of a good syllabus or reading list or whatever. So, and all the references that I have in this presentation will be there as well. But starting out, what is computational text analysis? On the face of it, it's pretty straightforward, and in a lot of ways it is, but let's break it down. First of all, computational, having to do with computers or using computers. The point being, among other things, that we have just a mass amount of data now and not enough time to analyze all of this text. And we use computers to help us do stuff much faster that we probably could do if we would live forever or something like that. But it can also do computers also help us to do very more complex things we might have difficulty doing at all. Text, this again seems kind of straightforward, but this is the definition I came up with because of reading other things: any object that can be read. And most of the time we think of this in terms of written or spoken language, and social, cultural scholars have shown, and I think our intuition is, that this sort of language, it contains within it a structure that reflects things like as groups of society, our morality, our hierarchical structures of status, what's important to us, all of these sorts of things. So that's one reason we focus on those types of texts. We also just have a lot of those types of texts because it's our primary mode of communication. But in my work, for example, I look at artworks as texts, as objects, cultural objects that have meaning, and that meaning is kind of derived from things like color, content, texture. And I look at these vectors that are just numeric, but I'm thinking of them in a very similar way to the way we think about texts. And so I would just encourage you as we go through this, maybe you're not a more linguistic text analyst, but maybe your data could be analyzed with some of these methods. I was thinking this morning, I don't know of any case, but using a topic model on something that's not language text, and I don't know what would come out of that, but topic modeling was kind of discovered simultaneously in like population ecology or something non-textual, and with David Blay, who's the one who's been cited a bazillion times with latent Dirichlet allocation. So originally, it was thought of as possibly not applying to texts, linguistic texts. And then analysis, hopefully, if you don't know what analysis is, we have like a whole other lecture. But there's probably a lot of definitions for this as well. I came up with the systematic examination of the structure or mechanisms of something. So if we put all of this together, computational text analysis would be systematic, computer-assisted examination of the structure or mechanisms of readable content. And that's great, but it also makes it sound a little bit boring. And in particular, as social scientists, we want to think about what analysis means to us. So Hopkins and King, in their article on text analysis, say this: policymakers or computer scientists may be interested in finding the needle in the haystack, such as a potential terrorist threat or the right web page to display from a search, but social scientists are more commonly interested in characterizing the haystack. So we don't necessarily, for instance, with topic modeling, focus on getting the correct classification of some sort of document, but rather are interested in the distribution of documents over a corpus. So that just keeping that in mind as social scientists, again, computational social science, how we're using these methods, because computer scientists or policymakers might use them in a very different way. Turning now to just the history of, we'll do this really quickly. The same article, The History of Computational Text Analysis, that same Hopkins and King article, note that the Catholic Church tracked the proportion of non-religious printed texts in the 1600s, and they kind of mention this as one of the first examples we have of like word count or some sort of content analysis. My intuition is there's probably a precursor to this in other parts of the world, whether the Middle East or Asia or Africa, but this is like a Western Delta, and King and Hopkins were going in that direction. So that's kind of, it started a long time ago, content analysis. But we usually talk about the modern era, starting with Laswell doing keyword counts. There's a lot of quotes from him for the intuition of content analysis of text for studying sociometric measures or measures of social dynamics. And those same methods of keyword count started to be used by social scientists in the 1940s. And then, of course, Turin in the 1950s in the context of World War II applied AI to study text, try and decipher foreign transmissions. And then as we moved along, we have the first textbooks on content analysis. We start applying mainframe computers to them, start doing NLP and event coding, and then we get these dictionary-based methods like LUIC for studying texts. And that brings us up until the 1990s when we have the first topic models. And then slowly throughout the 90s, these topic models get infrastructure and get started to used in other methods like network methods of text that we'll discuss later, start to get used in a little bit previous. In like the 70s, we have the first embedding models, not necessarily word embedding, but embedding models. And then in 2010, King and Hopkins and others start really bringing topic modeling. This is kind of the main method that social scientists tend to use as their entree into computational text analysis is topic modeling. And that was just in 2010, which is a disturbingly long time ago, but also not that long ago. Like it seems in my mind to be not that long ago. And in 2014, Molly Roberts and her colleagues developed structural topic modeling, which we'll do a tutorial on later. But one thing that's interesting about that is that it really was a content text analysis designed for social scientists and sociologists interested in demographic characteristics. And then we have today, which I believe is June 19th. And it's all of us doing whatever we're doing with text analysis. And like I said, it's pretty easy to jump to the cutting edge, building off of everything that's come before us. So getting the data, Ridi talked about this quite a bit yesterday, so I will not do too much on it. But where do we get the sort of data that we use with these methods, these computational methods that we'll study later? largely lately, one of the things that has really pushed the development of text analysis forward is the fact that we have tons of content from the internet, including social media. So here, there's some examples. As already mentioned, Twitter has been very good at helping us get its data, and so a lot of studies come out of Twitter data. Pablo Barbara, who we'll hear from later, is this birds of the same feather tweet together, just looking at the network structure of Twitter and trying to predict ideology of political leaders, and then kind of comparing that to what they actually say. Munger, this great title, Tweetment Effects on the Tweeted, experimentally reducing racist harassment, was looking at similarly on Twitter if you could use bots to kind of censor people who were harassing others. We have studies on the effect of wordage in terms of how popular a message becomes. Reddit is another source of data that's really interesting. This study looked at, there was a ban in 2015 for hate speech on certain subreddits, and they just wanted to see, did it actually diminish hate speech, or did these people and the hate speech just kind of bleed into other subreddits? Similarly, analysis in Facebook, Kickstarter, what makes for a successful Kickstarter campaign based on the language. We talked about this one at lunch, some of us. Self-disclosure and perceived trustworthiness on Airbnb. So as a host on Airbnb, if I disclose more about myself, is it possible that that the people looking for housing will trust me more based on text analysis? And then this one by King et al., they use a lot of different social media platforms to look at Chinese censorship. Outside of social media, there's open-ended surveys, historical archives. This study by Bierman and Stubble used historical interviews with former Nazis. This one was looking at texts from the Qing Dynasty from 1722 to 1911. I just came across one by Mark Anthony Hoffman from Columbia, but he's moving somewhere else. But he looked at the Bible and how different, in the US kind of revival era, how different pastors in their sermons cited different Bible quotes or passages. And Enron emails, political documents, including the State of the Union in the US, which is a speech given by the president once a year, and of course newspapers. And beyond these more specifics, we've got these massive corpora like Google Ngrams, which is millions of books from 1500 until 2008, maybe even more recent now. English corpora is an interesting one that I don't think a ton of people know about for some reason, maybe because you have to pay for it and we don't like doing that. They have some great corpora that are historical, they're subdivided by type, and then some that are very updated daily, and they're quite large. The Manifesto Project has political stances by by over 1,000 parties from 1945 until today in 50 countries on 5 continents. Spinner Internet Archive is another really interesting one. If you're ever wanting to save a website and the text on that website as it is today, but you don't have time to scrape it or don't know how or whatever, you can just go to Internet Archive, place the URL, and it will store that. It's literally an archive of the internet. So, for instance, when there's maybe political transitions, as we had, in the U.S. a few years ago, people were worried about certain political government departments like the EPA, and so there's going to be changes when there's a change in presidency to these websites sometimes. So people went and just archived all of those web pages, so you had a static version of what it was like before and after the transition. But this has just tons of resources for texts. Any questions, comments, other resources that are dope? Yeah.
There's one Diane and Nick Shapiro and the group Public Lab, I'll put it in the Slack channel.
Okay.
But it's the Data Preservation Project.
Okay, the Data Preservation Project.
I'll double check that.
Okay.
It's a full resource.
Cool. Yeah, so anyways, there's tons out there. And how do we get at it? We talked about this a little bit yesterday, but open source or API is obviously ideal, especially if the open source, as we talked about, isn't from a hacker who just dropped it there for you, but is actually open source. Someone has said, you can have this, or an API where they give you a structured way of getting it from them. A private agreement, my dissertation data is a private agreement with a company. Those aren't always easy to come by, but they can be quite nice. Purchased, like I said, the English corpora is one that you can purchase, but you can purchase mass amounts of Twitter data with the fire hose as well. And then, of course, scraped, which we've talked about, and terms of use on that one. Or, as we said, maybe you don't care, but I would say check the terms of use. And then once you have your data, you need to do some preparation before you can analyze it. So I wanted to take a poll of those of you who do text analysis. How many of you use Python to kind of clean and prepare and analyze your data? Okay, maybe 5. And how many of you use R? Oh, okay, a little bit more, but not a ton more. If you use R, do you use the tidy text packages for cleaning your data? Yeah, for the most part. Okay. So in the Princeton Core 6, on the computational text analysis slides, my and Aiden's advisor, Chris Bale, is teaching that, and he has tons of examples of tidy text, and so we talked about it at lunch. Like, I think that is, I love tidy. I love the tidy universe, especially for text analysis. Anything by Hadley Wickham seems trustworthy. But I thought I would introduce us to a different approach. And so when we do our tutorial, we're going to use the Quantita package. Does anyone use that? Which is, it's different, very, very similar, but different. And I think it's just nice to know what tools you have at your disposal beyond the tidy package. But okay, before we get to that, let's say we now have a corpus of data, a corpus of text that we want to analyze, and we need to pre-process them. So maybe it looks like this. This is actually a piece of scraped data. I have to admit, I didn't look at the terms of use, but it's just a small bit. And as you can see, there's not just text. This is some sort of contemporary art criticism document. There's not just text. There's Unicode, non-ASCII characters, there's HTML, and we don't really want to analyze those, probably. And in the context of R, largely what you're going to use to get those out are regular expressions using grep commands, which stands for globally search a regular expression and print. And we similarly over break, we're talking about how we all kind of hate regular expressions. They're cumbersome, and there's a ton of packages in R that you can use that have them built in, so you don't really have to think about it. But I do encourage you, if you want to do text analysis, to just especially if you're doing it in R, to just get familiar with the regular expressions. And I'll share this later. There's some sort of app online where there's crossword puzzles that you can fill out using regular expressions to get better at it. But they can be a pain. But this is kind of what it would look like in the code. You would define a variable as whatever your text is, and then this is one of the ones that's the methods that's in base R, so you don't have to load a package, but it's just G sub. And what we're trying to do is we're saying find this pattern, the tab object, and he's touching, and replace it with a blank in this variable text, and it comes out, and you haven't removed the HTML or the Unicode, but you did remove that. So this is kind of the intuition of all the regular expressions for cleaning. Obviously, like Unicode, for example, is a whole system of codes that code special characters in text, and you're not going to want to do each one of those as a regular expression yourself. And that's where some of these built-in packages that have already coded that up for you can be useful, but sometimes they just don't work. And so it's really good to get to know your regular expressions. This is another one for taking out the HTML. So you're just submitting anything in these brackets, which is how HTML code is often written, and replacing it with nothing. And then you have this is defining it as a function, so you could just feed your text to that function and it would remove all of the HTML. But here's a cheat sheet that you can go to that has a whole bunch of regular expressions, and you can start to learn. And I will try and find the crossword puzzle in case you are interested in that. But after cleaning all of that out, this is ideally what your text looks like before you start to analyze it. And there's a few more steps in preprocessing that are optional and more substantive decisions, I think, and we're going to discuss these. But what you love is this, just this clean text where you don't have other code, you don't have extra white spaces. Yeah. Any questions or comments on that so far? Okay. So as you go about preprocessing a little bit further, we have things like stop word removal, which I'm pretty sure everyone in here is familiar with what stop words are, but they're basically just very common words that aren't really substantive in terms of if you're looking at the topic or content of your text. So things like at, the, and, etc., but it might be corpus specific to you. Maybe when you're looking at, I don't know, some sort of religious text, you really don't care about a certain religious object. You just want that removed because you don't want to analyze that over and over and over again, or specific names that you want removed. You can add those to your dictionary of stop words and remove them, and when we do our tutorial a little bit later, we'll see how to programmatically remove stop words. Then there's the options of stemming or lemmatizing your text. Stemming removes the endings of conjugated verbs and plural nouns, returning only the stem of the word. So in this case, running would become run, and the verb saw, like I saw something, would remain saw. But if you lemmatize, you actually get to the base of the word. And so the noun saw, like sawing a piece of wood, would remain saw, but the verb saw would become see, because that's its base form. So then seeing, saw, and see would all become see in your text. And if you think about it, these can be very substantive, and there has been research that has shown that you will get different effects in certain contexts if you lemmatize or if you don't, or if you remove certain stop words and not others. And so you'll want to think about that. And this, I think, comes back to what we were talking about before, that in this kind of Wild West, in some regards, of computational social science, we don't necessarily have standards of reporting. But whenever I review papers that do things with computational text analysis, I do ask the author to provide, if not their code, so we can just see what stop words did you remove, then the code and robustness checks for what happens if you just change some of those parameters around. Ideally, nothing would change, but sometimes it does. Other options in preprocessing are to create n-grams in your text. So just base tokenization, meaning the token is just like an individual unit of text. You can treat them as unigrams, where it's just each individual word. So something like New York City would be separate, New York and city. And if we do something like a topic model or an embedding model like we did later, those are probably likely to show up in the same cluster or topic because they're technically the same entity. You could do it as bigrams and just get New York and New York City. And there's certain n-gram kind of processes that will help you predict which n-grams are actual n-grams just based on how commonly they show up. And so York City probably would get kicked out because that doesn't happen as much, but New York would stay in. And then you have New York City, which is the trigram. And you can get longer and longer if you like. You can identify parts of speech. So this is kind of a common output of a part of speech tagging, if you want to identify which of your words fall into which part of speech. So we have like a singular noun and a plural noun and a verb. And maybe you want to do that, so then you remove all adjectives or you remove all nouns. There was a professor in our department, somebody mentioned multiple people mentioned moral foundations theory previously. He was interested in doing topic modeling where you removed the nouns. I can't remember now, but basically looking at trying to get the moral foundations by clustering only adjectives. So once you have them attached to their nouns, then you get rid of the nouns and you only look at the adjectives to see how the clusters of like morality around words are shaped in different corpora. And then identifying named entities, which is a subtask of information execution that seeks to locate and classify named entity mentions in unstructured texts into predefined categories. And I have a little tutorial that we're going to go through using the Google Named Entity API. There's others, but it's kind of neat because it will return, you send it the text, it returns the text, and it picks out things it identifies as named entities. If there's a Wikipedia page associated with it, then it'll give you the link to the Wikipedia page, and it gives you some, like whether it's a person, a place, an institution, so you can start to get at what other entities are spoken about in your texts. And so yeah, that's the point now that we're going to move on to the tutorial for pre-processing. Some of the things we just discussed, we're going to code them. And that, I think I have a slide for it. Oh, but right before we do that, when we come back, we'll talk about analyzing the texts. I just wanted to make sure that you all have access. Did you all get access to the materials? I sent the link on Slack. Raise your hand if you don't have the materials yet. You don't. On Slack, there's a bit.ly link. It's bit.l/SICSS-Oxford. And all of the materials, the tutorials for data, and the data should be there. I'll come to you right afterwards. But yeah, we'll clean the text, and when we come back after the break, we're going to analyze the text. And I thought I'd just give a precursor to that in terms of in the computational analysis worlds, we've all heard these terms supervised, unsupervised, and semi-supervised, the different methods that you can use in like machine learning and these sorts of things. And I just wanted to make sure we're all on the same page as to where we fit within it and where these methods that we'll learn fit within it. So in supervised text, you give your algorithm or whatever you're working with computationally a set of labeled data, meaning that maybe you have multiple cases and you're saying this is a woman, this is a man, this is a woman, this is a man. And the algorithm will train on that set and then help you predict a set where you don't have any of that data. With supervised data, you don't have any labels to begin with. You don't have what topic does this word belong to. You don't have, is this a male or a female candidate? Are they at high risk or not? But it just kind of uses, without really supervision, trains and starts to predict what those categories might be. And with semi-supervised, it's a combination of these two things. Usually it's something like you have some labeled data, but you have a ton of unlabeled data. So one way you would do that is you would take your labeled data and train an algorithm, predict some section of the unlabeled data. Now they have labels, and you bring them back in and train the analysis, then you train more, and it's this kind of cyclical process. The things that we're going to learn, topic modeling, word embedding, and network analysis, are largely unsupervised, classified as unsupervised, because a lot of times we're just feeding it data and it's giving it something out. But in the context of social scientific research, I put it a little bit more in the semi-supervised, not in the sense that we're adding labels and then retraining algorithms, but that we are very intentionally informing the algorithm by our own substantive knowledge, which we'll talk about further, that these sort of methods for us are not things, as Chris talked about, or Matt, in their introduction to computational social science. There was maybe hope. I think it wasn't as broad spread as we sometimes like to think, but there was hope at the beginning that with tons of data we wouldn't need theory anymore, and we've learned that that's really not the case. And that's true with these methods too. Like topic modeling doesn't mean you don't have to read your text. In fact, it's very important that you're familiar with the text and the corpora that you're working with. So it's kind of like unsupervised-ish, just because the definition of semi-supervised is a little bit different. But yeah, when we come back, these are the three methods we're going to work with. But before that, we're going to clean our data. Yeah?
I have two tips I stumbled upon in my own experiences.
Yeah, can you give him the mic? Thanks.
Yeah, thank you. I just wanted to add for the pre-processing steps that there were some things I ran into at some point which really helped me. First of all, if you have text in different languages, you can easily use the Translate API.
Oh, yeah.
But then also, it can help you to actually get out spelling mistakes. So if you translate it to a language and then back again to English,
oh, clever.
actually fixes. In general, you have also pre-processing steps where they do edit what do you call them? Spelling errors. They take a long time. It's text blob, I think, for R.
Okay.
And then last thing is that you can use fuzzy matching if your data has a lot of names of companies, that kind of stuff. They're all mentioned in a different way, or with or without the and, inc, and etc.
Yeah.
To actually get them together. So those are two steps that for me in pre-processing were very helpful to.
Those are both really great points. I think the fuzzy matching is often used when you have, things like Disney Inc. or Disney. It's like the same thing. The named entity stuff can sometimes help with that as well, because they'll have the same URL attached to them or something, but those are both really great points. Anyone else experiences, we could go on forever, I'm sure, with horror stories of data cleaning, but what about anything you've learned or, okay, maybe they'll come out during the tutorial, which is what we're gonna switch to now. So the script that we're gonna start with, it's the HTML file for the Quantita. I think it's just called Preprocessing. And now we're going to switch to the HTML. So I'm turning myself off. Oh, yeah, anyone on the live stream, the link to these materials are in the HTML files on the bit.ly link that you should see on your screen as soon as we turn off the slides. We're back. Just a reminder, anyone on the live stream, there should be a bit.ly link that you can follow. If not, it's bit.ly/SICSS-Oxford. And the file that we're looking at is the HTML on pre-processing text. And as I said, we're going to work mostly with the Quantita package, but also some things from the tidyverse. And I'll just walk through it, and anyone can ask questions. Obviously, anyone with experience in R or Python, but particularly R, R or Python. There's like a million ways to do any one thing that you want to do. So I'm just showing one example, but if you know of a more efficient way or anything like that, feel free to interrupt. So first we're just going to load the packages and then load the texts, which, as I mentioned, is just a set of abstracts from sociology between, I think, 2008 and 2000 and like halfway through 2012. And you see here with the printout just kind of a preview of what the data looks like, what the data frame kind of looks like, what the source, which journal the article came from, who the first author is. I didn't extract all of the authors, only the first author, and the year. And then that's just kind of a thing so you can track back to which file it came from. Other ways to read in your data, obviously your data can come in a ton of different formats. And this read text, I like read text a lot. There's also reader, read R function that's pretty great. But for Quantita, this read text is pretty great. There's one for just tweets that reads in Twitter data. Again, that's just representative of how prominent Twitter data compared to other things are, that we have a unique read-in package for that. JSON, text files, multiple text files. Say you have I often have this, you have a file on your computer with a ton of text files and you don't want to load each one individually. If you just, why it doesn't, okay, I'll stay over here. If you just write your path and then star.txt or whatever the outcome of the format of your text is, it will read in all of those. And then within Quantita, for the analysis, you also have what they call doc variables for the file names, and you can pre-specify those. And we'll talk a little bit more about them. In this case, on that myTF5, it was reading in the State of the Union address, which again is a US speech by the president. And so it was saying which president and which year. XML files, CSV. One thing that's really neat about read text is that when you read in text, you specify, you declare this parameter text field as to what the column or field within your original file, where the text is, how it's identified. And it reads it in and it names it text. So that if you say you had a document where you had a bunch of different CSV files and the text column in these different CSV files was named slightly differently. When you use this, it will rename all of them text, so you don't have to do that yourself. This is me. I don't know how, with the Quantita package, how to deduplicate the text. There might be a way. So say you have, maybe when you were scraping, you accidentally saved, or the same web page has two different URLs, and you captured both of them. So it's the exact same text, but some of the other metadata is different. And so just doing like a dedupe on the data frame at large wouldn't work. It's only deduping the text. I used dplyr for that. So this is basically just taking our sociology data frame and then grouping it by the text ID. Anyways, it's deduping that. If we want to explain it further, I'm happy to. But this is one way that you could remove multiple texts if the other metadata about that text was different. Might be risky, though, because maybe that metadata is really where the important difference lies. But let's run that. I don't think for this particular corpus there were any duplicates, but I definitely have duplicates in contexts where I scraped data. And then in Quantita, similar in some respects to other packages, you create what's called a corpus, which is designed to be, as it says, a library of original documents that have been converted to plain UTF-8 encoded text and stored along with the metadata at the corpus level and document level. They have these special document level metadata called doc variables, which are variables associated with the document. So in the case of our sociology abstracts, instance of the doc variable would be what journal does it come from and what year was it produced. The corpus in Quantita, as it says here, is not really designed to be where you conduct your analysis. It's like it's your original data. Kind of when you were first learning Stata or SPSS or something, it's like, don't change the original data. Don't touch that, right? It's similar to the corpus. It's where, if you want to do multiple different analyses or robustness checks, that's where the original data lives. So we're going to create a corpus out of right now, our data frame is just like, it's just a data frame, a traditional data frame that with the text and whatnot. And now we're going to create this special object called a corpus and take a look at that. It looks pretty much the same, but the formatting, the metadata of a corpus is slightly different and allows for certain Quantita analyses. If we want to add document level variables that weren't originally in the import of the data, so again, a doc variable would be like the journal or the year. Say we wanted to create one on the fly. So in this case, just because it was what I thought of first, we're going to identify two of the prominent American sociology journals, American Journal of Sociology and American Sociological Review, which a lot of people would love to have a solo authored or an authored paper in one of these. So I thought those are like kind of the paradigms in US sociology of like a prestigious journal. So I'm going to use that as a heuristic for like tip-top journal publication. And I'm just going to make a binary coding of that. So here we're only getting the first 5 examples, but you see there's this new variable, AJS, ASR. None of these first 5, as you can see, they were in the sociology, religion, or symbolic interaction. All of those are not in that journal, so they have a value of false. But we've just created a new document variable. Is this document from AJS or ASR? There's many other ways, as I mentioned. regex would be your friend for creating new doc variables, but this is just one example. Any questions? All makes sense? So if we wanted to add a corpus level variable, which is not about individual documents, but the corpus as a whole, we would do that with metadoc. And I just added the date yesterday, which was June 18th. And that's kind of just a meta information about the corpus. You could add like who collected it or who created the corpus if you plan to make this open source in the future or anything. But that could be a really useful place for you to store metadata about the corpus. And to take a look at an example, we just want to say look at the text of the first, I'm looking at the second abstract here. This is an abstract from, I believe it was the sociology of religion, right? This is what the text looks like. Luckily, it's pretty clean in terms of, like we said, there's no non-ASCII characters or Unicode or something. So we can be happy about that because that's a luxury. If we wanted to summarize a bit about the corpus, I'm just summarizing here the number of abstracts by year. I don't know why it didn't come up. There we go. So yeah, like I said, it cuts off partially through 2012, but it looks like there's approximately 1,500 articles for each year. If we wanted to see which text is the longest, it looks like there's 501 tokens in one abstract. It's kind of like they want one word over what is often our limit of 500-word abstract. If you happen to have more than one corpus and you wanted to combine them, pretty simple, just a plus, just add them together. If you wanted to subset your corpus, here we say we only wanted to look at 2010. This is how we would do it. Let me move this over so it's not cramping our style anymore. And then we can begin to explore the actual text itself. So if we wanted to see, for instance, I study art, I want to see which abstracts mention the word art and in what context. So here are some. It tells me which abstract it's from and then the context of it. So I argue there is art exertion. Who knows what due to high, I don't know what that one is. Average consumers of art and culture. I could maybe then start to maybe look specifically for things that are relevant to my own research. The practice of art as prayer. Or maybe this kind of exploration starts to give you ideas of what sort of topics there might be if you're going to do a topic model or something like that. So you can start to explore your data. And there are evidently a lot of art. Okay. You can inspect the document variables that you defined or the meta-corpus variables that you defined. Those we've already kind of talked about. Then when you want to perform your analysis, as is often the case, you're going to create some sort of term document or term token matrix. There's often the TF-IDF, term frequency document infrequency matrix that you use in topic modeling. In Quantita, at first, it's literally, I believe, just a document feature matrix where the features are the columns and the features are the words, and then you have the documents. And there's a lot of different ways to tokenize. As I mentioned before, a token in the context of text analysis is like a unit of analysis. And that might be a word, it might be a whole sentence, it could be bigrams or trigrams, it could be only punctuation. It's whatever you want. So I'm just going to show within the context of Quantita all the different ways you could very easily tokenize. And we're starting with these 3 sentences that I came up with that if anybody can identify which sources they're from, I'll buy you a drink or coffee later. So in this case, these are the texts, and we're just tokenizing. The basic tokens text is just going to split it into words. It's not looking at bigrams or trigrams or sentences. It's just words. So it's split. If you're happy in a dream, does that count into if you're happy in, etc. Right? But there's all of these parameters that you can set in the tokens function, like remove numbers, remove punctuation, remove symbols, remove separators, remove Twitter things like hashtags or @ signs, remove hyphens or remove URLs. And I'm not going to go through these, but if you run these different functions, you'll see how doing the same thing results in a different result, or results in different tokens from those sentences. And as we talked about before with n-grams, the token can also do n-grams. You just specify n-grams. So here with n-grams 1 through 2, I'm saying get unigrams and bigrams. If you did 2 to 3, you would only get bigrams and trigrams. If you did 1 to 3, you'd get, etc., unigrams, bigrams, and trigrams. So here, that same sentence, let's look at the shortest one. If you're happy in a dream, does that count? Also has if you're happy, happy in a, etc., right? You can also, this definition, characters. So instead of words, I want characters. I don't know why you do this, but which is why I said, why would you ever do this? But it would split it into letters. If you're thinking maybe you would do it to count the number of characters, there's an easier way. But there, it's possible. Or you can tokenize by sentence, but each of these is only one sentence long. Oh no, this is this one, okay. So this is not nom, this is bowling, there are rules. Similarly, if you can tell me where that's from, you get a drink or chocolate or something. But it'll just split it into sentences. Now sentences are your unit of analysis. They're your tokens. Cool? Super cool. Okay. Now, constructing the document frequency matrix is similarly quite easy in Quantita package. It's just this DFM. In the tokens, it didn't do anything unless you told it to, right? It didn't lowercase, it didn't remove punctuation, it didn't do any of that unless you specified that that's what you wanted. With DFM, it will do a lot of that. You can override it, but it will do a lot of that on its own. And so you won't have, it's not showing me. You won't have to specify, and you won't have things like, if it appears at the top, the beginning of a sentence, you won't have it capitalized, and so it's counted as a different token. It'll be the same token if it's the same word. You can also remove stop words and stem, which is what we talked about in the tutorial. So it's really easy, just defining you want to remove English stop words, and you set stem to true, and you want to remove punctuation. Looking at what types of stop words are in this English dictionary, it's I, me, my, etc. But you can add to it yourself if you want. Like I said, if you wanted to remove, maybe you're analyzing text messages or something, and they're all yours, and so your name is there a million times, and you're like, I don't want me to be there. You could add your name as a stop word. Sorry, guys. That'd be very interesting to analyze your text messages. I've never done that. So this is an example of that, adding the word will to the dictionary of stop words to remove. Then this top features function. Oh, I have to define that. We'll just show you the top features, the top words that are occurring in your corpus. So in this case, unsurprisingly, maybe social is top. Data, study, research, article using health, women results among religious also work. It's kind of like a sentence. So yeah, these are some of the top tokens or words used in sociological abstracts. You can also make a word cloud, which I kind of love-hate word clouds, and this takes a while to run. It's in your HTML. You can see it with some like ungodly palette that was selected to go along with it, but I shouldn't have clicked on that. You guys know what a word cloud looks like. There you go. Ooh. It's very tropical. You can also group documents. Sorry, yeah.
The sizes of that, the font size correspond to
the word size.
Yeah.
Yeah, the font size of the words. Yeah, it's how common the word is in the corpus. Yeah. You can start to analyze by groups of text. So in this case, maybe you want to create a corpus or a document frequency matrix by year to analyze them separately. And so it would do that. So here now we're able to see, like, say that we normalize the number of tokens across years. You could see how they like go up and down. This is just raw counts, but it looks like health was really more popular in 2010 and went down for whatever reason in 2011. And they have nearly the same number of documents, if I remember from the histogram at the beginning. So that's one thing you can do. We're not going to, well, maybe we, yeah.
What if you have sort of two parameters? So is it more advisable to have a document to a matrix where in this case, your rows were sort of the years, right? And your columns were all the sort of possible tokens.
Well, it's still like the same matrix of just the documents and the features or the tokens.
Right.
And then the analysis just does that by year and gives you this table.
So it's stored in a list? Is every single like document term matrix stored in a list? And the Corpus, just by typing sort.dfm, or like, I don't know what the command is, but like produces that header for you, or?
Yeah, it produces the header for you. The matrix is just a matrix, which is a bunch of lists, in the columns. But then separate is the corpus where the metadata resides.
Right.
And it's just drawing on that to create this table for you. Yeah.
Because, when I'm interested in, for example, creating a document term matrix that groups alongside two variables. Right?
Okay, yeah.
And so that wouldn't really. So I'm just wondering, like conceptually, sort of in a two-dimensional space.
Yeah.
I would probably create a matrix by sort of one category and then group it in a list, right?
Yeah.
Okay.
Yeah, I'm trying to think offhand because you want like all of the different combinations of your two features. I don't think there's a straightforward way to do it with Quantita, but using two features. There might be. You could look in the documentation. But it's definitely doable. Yeah. Sometimes we have, as it says, some prior intuition of words that are particularly important inside of our text, and we might want to know how those relate. This shouldn't be women. It's probably incorrect. I was looking at men and women, but then I switched it to culture and structure, which are two common. We have previously thought of them as either oppositions or ends of a spectrum within sociology. There's obviously a lot of theory there that would argue against it, but just in terms of how we use it in abstract, maybe we're interested in how those would be used separately. And so we could just get a count of which one's winning. Do we talk more about culture? Do we talk more about structure, right? And according to the first 5, we talk more about culture. But culture is structure to some people. So here you can use external dictionaries. So maybe you want to do the same sort of thing, but you want to look at like Luweek dictionary terms. You have to pay for those, which I didn't want to do last night. So I just gave you the code for how you would import those terms, and then you could do the same analysis looking at the frequency over time. You can look at the similarity of texts by running this code. I don't know if this will show up actually. Based on like cosine similarity of the term document matrix. Might take a little bit. So this is just giving you an example of the cosine similarity of the first document with other documents. You could then use those as weights in a network analysis or something. I'm not sure. You can do the same with specific words. So if you wanted to look at how race, the cosine similarity of race with other tokens in your corpus, it looks like it has a very high similarity with the word racial, which maybe isn't surprising. If you go down to the gender list, they're kind of intuitive as well. Let's see. So with gender, women is the most similar term associated with, but then men, equal, differ, male. Remember, we stemmed these, so equal could be equality.
It's like a correlation or something?
It's a cosine similarity from the document term frequency matrix. Yeah. And then, we're not going to do this because we have a whole tutorial on structural topic modeling, but within the Quantita package, you can do topic modeling, and it's pretty straightforward. So here you're just identifying how many topics you want, and you're saying I'm going to use latent Dirichlet allocation, and then you get the terms and the topic distributions. So if you want, you can start doing topic models that way. Yeah? Okay, it's 3:15. Should we take a break or? because I have two other scripts on pre-processing that I've provided, but you can also just play with those at your leisure. One would be a bit complicated for us to go through, but it's working with that Google API for detecting named entities, and that is, I think it's just called NLP. It's like the NLP tutorial. And there's another one on sentiment analysis. So in the Core 6 at Princeton, they do more work on sentiment analysis. It's pretty straightforward, though, like getting the sentiment. Just you give it a dictionary, and it looks at the words and tells you what the sentiment of those words are. By and large, like that's the most simple form of sentiment analysis. So it's not even a tutorial. I just provided you a script that you could use if you wanted to look at it, in case any of you want to do that in your group project and you want a base to run off of. But I'm happy to go through the Google named entity thing. Often there's credential, it's an API, right? So there could be credentialing problems, or we can just take a break.
Let's take a break and then.
Okay, we're going to do that. Unless no questions, right?
So are we supposed to run the code while you're talking, or is there not time like?
Oh yeah, so a lot of with the text analysis stuff, not necessarily pre-processing, but the models we run, a lot of them take a long time. So we're not going to do it live. But the HTML, and then I'll give you the markdown file later if you want it. You have it. You can copy paste later at your leisure. Okay. Yeah. Yeah.
What you said, but is there like a database with like a news or news outlet to retrieve text from to like media analysis? Is no public sort of database
With newspapers and things.
Yeah.
There are a lot. Yeah.
Okay.
I'm sure plenty of people in this room might know of more. I know, for instance, that EnglishCorpora.org that I told you about, one of their larger, I think it's called COCA, C-O-C-A, larger corpora, they subdivide the corpus into like magazines, blogs, newspapers, and within newspapers, there's multiple different newspapers, but like New York Times is kind of epically good of being able to get from their API text. I have a corpus if you want to just toy with it of New York Times. I think they're op-eds.